Good afternoon, new scientists. How are we all doing? Yeah, you could do better than that. I said, how are we all doing? Lovely. So we are on to the final event on the Engage stage today. We are very lucky to have the wonderful Dead Planet Society, who will be recording one of their new podcast episodes live here today. Can I get a woo? This is the most amount of people we've ever fit in the shed. You're lucky to get one other person in with me. We've got 4 in today, so it's a good job they're mates, isn't it, really? However, these people are going to be talking about outlandish ideas about how to tinker with the cosmos and subject them to the laws of physics. Everybody, can you please put your hands together? Can I get a shout? Can I get a whoop for the Dead Planet Society?
Hi, everybody. Thank you all for being here. We are here for the Dead Planet Society, which, as was previously said, is a podcast where we take our most outlandish, our most unhinged ideas about how to tinker and mess around with the universe and subject them to the real laws of physics with the help of actual experts. I'm Leah Crane. I'm a physics and space reporter at New Scientist.
And I'm Chelsea Whyte. I'm a senior news editor at New Scientist. And today we are going to be talking about some really fun stuff. We're going to be doing some real cosmic destruction. But before we get into it, I'm going to introduce our very excited guests. We have with us Lewis Dartnell and Vincent van Eylen. So Lewis is an astrobiologist and a presenter and author based in London. And he is also a professor at the University of Westminster. And he's appeared on numerous TV documentaries and radio shows. And he's also written a book, one of 5. And he's going to be signing it later today after this. The book is called Being Human, How Our Biology Shaped World History. And if you'd like to get that book and have him sign it, he'll be at the Blackwell stand at G1 just after this. And Vincent is also here with us. He's an astronomer and professor at the University College London, where he primarily studies exoplanets, which are worlds outside of our solar system. And he uses, those enormous data sets that they have from NASA and ESA, that they get from the James Webb Space Telescope to characterize exoplanets and their stars. So we're really happy to have them here today. And we all got together a little while ago and we were talking about how we could destroy some things in the universe, as we do. And we were talking about the worst planets we know of. Like, which are just the bad planets for life, the ones that we think are just the most miserable to be on. So we're going to start with that today. So Lewis, what are your worst planets?
Yeah, so I'm an astrobiologist. I spend most of my time thinking about where we could find life in our own solar system. And I don't mean little green bug-eyed monsters. I mean hardy, single-celled bacteria. And I spend most of my time thinking about our next-door neighbor planet, Mars, which you can see a huge version of behind us here at New Scientist Live. And Mars, we think, has got a good chance of having life on its own surface, hardy, bacterial-like life. But it's not exactly conducive for human life.
Yeah,
so for the sake of this thought experiment, let's imagine that we are having this conversation on the surface of Mars, and we accidentally pop outside for a stretch of our legs and a walk, and we forget to put our spacesuit on. We would die exceedingly quickly on the surface of Mars.
Yeah.
And one of the biggest problems with Mars is that its atmosphere is so very thin. It's about 6 millibars, so about 0.6% of what the Earth's atmospheric pressure is. And we need the atmospheric pressure to basically stop our blood from boiling. It keeps our blood from subliming and boiling it at relatively low temperatures. So I don't know if anyone's seen Total Recall, the original film with Arnie, not the more recent adaptation, which is awful. But there's a scene where Arnie smashes his helmet of his spacesuit and his eyes start bulging and popping out of his skull.
Yeah.
Wouldn't quite be that bad, but it would still be a pretty unpleasant way to die. And maybe one of the last thoughts to be going through your mind as you feel the saliva boiling off your own tongue would be able to see the Earth as a star in Mars's sky. You would have the
one beautiful moment.
You would have that poetic moment to be able to see home as you perished on the surface of an alien world.
Yeah, sounds pretty awful. pretty bad.
Horrendous. I think people talk a lot about moving humanity to Mars. It's pretty unpleasant as a place.
It is pretty hostile, yeah.
Even though it is potentially the best place, the best planet other than Earth for life.
Well, in many respects, it's the most Earth-like place we know about. It's just not all that Earth-like. At least not now. It was much more Earth-like we think in its past, which is why we're excited about the possibility of life there on primordial Mars.
What about you, Leah?
The planet I think is the worst also happens to be my least favorite planet, which is Mercury. It's really close to the sun, and when we think about a planet being bad for life, a lot of the time we think about it either being very hot or very cold. Mercury is both. It is tidally locked, so one side always faces the sun, and that side, which we call the day side, is about 800 degrees Fahrenheit, which is 430 Celsius, all the time. Absolutely awful.
Too hot.
Too hot.
That will give you sunburn very, very
little
quickly
too
on
hot.
Mercury.
A little too hot. Also, like, you'd get a lot of cancers from
Sure.
all of the radiation. And then there's the other side, which always faces away from the sun, which is minus 290 degrees Fahrenheit or minus 180 Celsius. Equally unpleasant.
Maybe worse. I don't like cold more than I don't like hot.
Yeah, potentially worse. And it's got very little atmosphere. There's very little going on Mercury. It's basically a big ball of iron with a little bit of rock on the outside that's too hot and too cold. So I don't love it, and I think there's the very thin band that would be okay, called the Terminator, which is the area between the day side and the night side.
Would you have
Well,
to
the
sort of
twilight
run
zone.
back and forth?
It's also called the twilight zone. You could stand right on the edge of that shadow, around the ring, around the annulus around Mercury, where the sun just hangs on the horizon forever.
Yeah. So that would be pretty awesome. But if you took a couple of steps in the wrong direction,
Oh, freeze.
Yeah, bad day.
oops. Yeah, so
I would say for me in the solar system, Jupiter is my least favorite planet. I don't like it. I don't understand why everyone thinks it's so beautiful. And
it's the biggest and best one.
It's not. We have this fight going back years. And, a gas planet is pretty bad for life, I think. It's pretty noxious in there. And then I think once you get down under the gas, correct me if I'm wrong, but it's kind of molten, right? Like at some point it stops being gas and it starts being, I don't know what.
Or
plasma?
metallic hydrogen, people
Right.
talk about in the very core, the very center of Jupiter, where the pressures get so unbelievably high that even the molecular hydrogen is being pressed together into a sort of new state of matter, into metallic hydrogen.
Yeah, so
with
I don't want
weird
to have a
properties.
house there.
Don't go there.
Yeah.
You'd be dead long before you get there. You'd be dead in the upper cloud next to Jupiter. Don't worry about that.
But then our Jupiter's not the only Jupiter, right, Vincent? There's hot Jupiters.
There is hot
Our
Jupiters,
Jupe
yeah.
is terrible, in my opinion. But a hot Jupe seems bad.
Yeah, hot Jupiter is kind of like a Jupiter, but much closer to the sun. So it's more like 2,000 degrees on there, pretty much everywhere.
Okay. So you're
Worse
just
than
cooking.
Mercury.
Worse than Mercury.
Worse than Mercury. Are there any sort of hot Jupiters you can think of that you've come across as you studied exoplanets that have like particularly horrific places?
Yeah, I would pick Hat P7b. So that's a kind of Jupiter-sized planet. It's roughly similar in size to Jupiter, but it has an orbit so much closer to its star that it gets around in about 2 days.
Oh, so it's flying.
There's one good bit, which is you'd have a birthday every 2 days. But other than that, there's not much good about it if you want to live there. It's a ball of gas. It's 2,000 plus degrees. There is winds that are several hundred or several thousand kilometers per hour going kind of from the side facing the sun for the star to the backside. They probably have things like sapphire rain. It's a pretty terrible place to be at.
Sapphire rain.
That doesn't sound too terrible to me, to be honest.
Kind of pretty, but
If you had a net, you could catch it as it fell.
but if you are just getting
If you're
cut
dying,
up by
if
it.
you're dying while you're fishing for the sap, yeah, all right, fair enough.
Yeah, might not
What
be
a way
good
to
chance.
go, though.
Well, I was also thinking about, we're talking about planets that are around a star, but there are rogue planets too, right? So these are planets that have been kicked out of their solar system, usually because another star comes by and sort of disrupts an orbit, or there's some orbital chaos with the planets and they get just booted out like traffic jam. And these, I first thought these would be pretty rare, but I was looking it up and something like 38% of solar systems have lost a planet in their lifetime. So there's lots of these rogue planets just kind of out there floating, cold and frigid in the vastness of space. And even the ones with the thickest atmospheres would freeze and be pretty miserable, yeah?
Eventually.
So there has been some research that looks at rogue planets, and they might still be able to have liquid water on the surface and be suitable for life if they're big enough with enough, sort of internal heat, like sort of heat that drives volcanoes on Earth, but also have a very, very thick atmosphere. They've got a really big, thick coat on that insulates them against that. But you're right, most rogue planets are going to be, far from the nearest star, far from their campfire of a sun, and exceedingly cold, and again, not the sort of place you want to find yourself on. But Vincent,
I think they would be pretty terrible, because I think a rogue planet, and you're right, there are probably many of them, it's kind of like an Earth, but then there's no more sun. It's like permanent winter, which sounds to me like probably the worst kind of thing to have.
Yeah, pitch black.
I was about to say that every day would be the same, but there would be no such thing as days.
Every night would be...
Always would
everything
be the
is
same.
always the same, yeah.
Which sounds pretty awful, in addition to all the research that suggests that having things be different from each other sometimes is very important for life developing. Having
you
tides
need gradients,
and things.
right? You need...
So I think those are pretty bad for life developing, and also if you got dropped off there, it would be kind of like eternal damnation a little bit. Just the same all the
Unsustainable
time.
might be the way to put it. Yeah.
So cold. Awful.
Are there other kinds of exoplanets that we can think of that might be pretty miserable?
Yeah, so when it comes to exoplanets, so planets around other stars, I think we know some 5,000 by now.
That's a lot.
And we've done research on quite a few of them, and on some we know more than others. And of course, one of the goals is really to find one that looks quite like the Earth, right? We actually want to find Earth copies, Earth twins of some kind, and that's been pretty hard. But we found, plenty that are not like the Earth and are probably pretty terrible. And it was kind of hard to narrow down to one planet that would be really terrible. So I picked 3.
Okay.
One is HATP 7, the Jupiter. That's really hot. Another one is also very hot, called Kepler 10b, but it's not a Jupiter, it's an Earth. So it's rocky, or it would be rocky if it wasn't so hot. So we expect that the whole surface is basically molten. So it's kind of like the floor is lava over the whole planet.
Yeah, that sounds bad.
So that's pretty bad. So that'd be my second option. And the third one, K222b, is a planet that's basically disintegrating. So basically the planet's kind of slowly falling apart. There's kind of like a tail of a comet kind of floating behind the planet. And so it's basically being at the end of its life and is being ripped apart. So I would pick between being ripped apart, having a lava floor, or the kind of sapphire winds, whatever you think is worse.
Options, but I think being on a planet that's being shredded while you're on it seems like the scariest one for sure.
Perhaps, yeah.
But on the other hand, why choose?
Yeah.
Here on Dead Planet Society, we have promised to make the worst possible world. So I think we should talk about whether or not we can combine all of the things that make all these worlds awful into one mega awful planet.
Yeah, the worst of all possible worlds.
So some of them aren't going to be feasible, like
or combining very hot and very cold just makes a lukewarm planet, I guess. Yeah. So you can't combine all extremes.
Well, but we did hear about Mercury. Could you have one side that's very hot?
If it's tidally locked, exactly.
Yeah,
Have a very hot side and a very cold side, yeah. But I think we talked about possibilities like a supernova, an exploding star going off nearby your planets, and that would make for a really bad day.
So what would happen? What would that day be like?
Well, it would last for centuries, for thousands of years. It would pummel the planet for a while. You would die quite quickly on the surface, but you would see an immense flash of light, which is what we see with supernovae in our galaxy and other galaxies as well. And with that would be a surge of radiation, which would shred up your DNA, give you all the mutations and cancers that would end up killing you. But also that flood of radiation would start stripping away the ozone layer from a planet like Earth, and then if it's not the radiation from supernova that kills you, it'll be ultraviolet rays beating down from the star that you're orbiting would kill you, and also make the worst kind of acid rain, make a lot of nitrogen dioxide in the atmosphere, which would dissolve in the water and fall as super acidic rain. So there'd be many, many things all going wrong all at the same time if a star would explode too close to our Earth or another Earth-like planet.
Let's just be very clear that this isn't
it's not about to happen.
But will it happen in the future, in the far, far future?
Well, as the sun orbits around the center of our galaxy, the galaxy is sort of swirling around, so we're coming closer and further away from other stars. So 10,000 years, 100,000 years in the future, the night sky will look very different because all the stars have moved around. So you might get a sort of drive-by where a large massive star swings near to the Earth and the solar system, and through really bad, unlucky timing, chooses that moment to pop off and explode when it's nearby to us. There is a star that many of you will be familiar with, which is one of the shoulders of Orion, called Betelgeuse, and that is a super red giant star at the moment, which will go supernova at some point in the future, but thankfully is very far away. As in far enough away that won't be a huge problem for the habitability of the Earth when it does explode. It would be an awe-inspiring sight, though, when that goes off in our sky.
Well, so here at Dead Planet Society, we give ourselves magic powers to do whatever we want in the solar system. And so I'm wondering if we could put a planet, a perfectly nice one to begin with, around something that's not a star. Like, what if a planet was orbiting a black hole? What would that be like? Would it be horrific? Would it be as terrible as I want it to be?
That depends, I think. If you're far enough away from a black hole, you could imagine you're still in orbit around it, and you'd be more or less fine. There'd be no more star, really.
No light.
But you'd be more or less fine. So I'm not sure that's the worst. I think something like a pulsar star, which is a star that's kind of beaming radiation the whole time.
Oh,
and we
yeah.
actually know some planets around a pulsar. That sounds really terrible, and it's probably worse than a black hole, maybe counterintuitively.
Because pulsars are spinning, right?
Yeah, so they're spinning and they're releasing high energy radiation the whole time. So you'd be kind of blasted or beamed by radiation very regularly. So that would be bad.
Like sitting
or
in
you
front
could,
of a lighthouse.
Yeah,
put
like the
a lot of
universe's
meteors
worst
or
lighthouse.
asteroids around you. That seems pretty terrible as well, like things falling from the sky all the time.
Yeah, a planet in an asteroid belt.
I think that, so there is a problem with that.
Oh.
Because currently, according to the definition that the International Astronomical Union has made for what is a planet, you can't have too many asteroids or meteors near you. That's why
Right.
Pluto's not a planet.
Right.
But if you change that definition, and I suggest we do, so we can have Pluto back.
You're going to get off on a technicality.
Right.
is
So
that
we can
what-
have
that's what you
Pluto. We
mean?
can have Pluto back.
Yes.
But once you have that, you could be in a kind of asteroid belt as a planet, and then you might have asteroids kind of raining down often. And that would be. I think it's maybe interesting the first time, but it would get old after a while. And dinosaurs didn't like it eventually, obviously, either.
Yeah, it was a bad day here for them, wasn't it?
Yeah,
Good day for
it's-
us, in fairness, though, for
Yeah.
mammals. It gave us our bite of the cherry, gave us a chance.
It seems like some of these are really very similar to the much earlier solar system. So it's funny to think that the worst planet, I don't know, could have been Earth 3 billion years ago when there were lots of rocks and stuff coming in and things were a bit brighter and the surface was molten because of the collision that produced the moon. Seems like potentially ages ago Earth was one of the
Maybe.
worst worlds.
And with no oxygen to breathe as well. So you go back more than about 2.5 billion years in our past, and you need a spacesuit to walk around even on the surface of the Earth. Like our Earth would have been an alien planet, as far as we're concerned, if you go back far enough. Before the atmosphere evolved.
Yeah, I mean, I guess what's terrible depends on your perspective, right? Terrible for us, it's easy to find things, but it's hard to know what's terrible for everyone. I sometimes wonder if an alien were to look at the Earth, they might think it's pretty terrible. Like they might say, oh, it seems to spin every 24 hours, right? Day-night cycles. Every 24 hours, you go from warm to cold. How can you'd never be able to survive on there?
There's no,
right? That's
there's no
miserable.
oceans of ammonia that you can
Exactly,
drink.
yeah. So maybe,
not enough
it's hard to know what
uranium.
terrible means. But
Yeah.
for us, I think there's plenty of options
But
that would
that's
be
a really
terrible.
good perspective, because when we're looking for signs of life on other planets, we have to make sure we don't have that clouding our vision, right? We're not just looking for things that would make life like us. There might be life completely unlike us. Is that something you guys think about in your work?
So it does pop up quite a lot in astrobiology. The problem with looking for life that's very unlike us is how do you kind of know what to look for then? So I think for the first effort, it makes a lot of sense to look for life that is like us, that is water-based, that is carbon-based, it's built from organic compounds because we're good at finding that kind of life. But then maybe a place like Titan, which is one of the giant moons orbiting Saturn in the outer solar system, it has seas and lakes and rivers and oceans, not of liquid water, but a liquid methane and ethane. So maybe there's methane-based life on Titan rather than water-based life, like all life on the Earth is. So maybe there are these really exotic alien biochemistries that are completely unknown to anything that we would understand.
I would agree. I think it's good to keep an open mind about life unlike us, but since we have to start somewhere, there's still this goal that we have in exoplanets about finding planets kind of the size of the Earth or the temperature of the Earth with a star like the Sun, because at least we know it's worked out here on Earth. And we also know what to look for, right? We know that life would produce oxygen and so on. So while it's good to keep an open mind, if we had to start somewhere, I would start with,
Sure.
Earth-like life.
Yeah, absolutely.
Yeah, I think it's easy for us to think, well, Earth's the best one, and Mercury is the worst
coming
one.
from an Earthling, that's quite a rich.
Yeah.
You're just biased, aren't you?
Yeah, just
Water
biased.
drinker.
The Mercurians are going to be angry when they hear this. But I think maybe...
But there are some other non-Earth situations that could be pretty bad, right? So what if there was a planet that was in just like a very busy area of space, like a stellar cluster? Like, I'm curious, because space is so big and so vast, and I always forget how much of it is out there.
Yeah.
Like, how smushed together could a planet be? How busy a neighborhood could it live in and still not hang together as a planet?
Well, the solar system did form as part of a stellar cluster, and then they all kind of drifted off and went their own way. And there have been research projects looking at trying to identify the sun's siblings, trying to find stars with very similar spectral characteristics. They might have been born as part of the same family. But one of the problems for a planet with life on it, being as part of a star cluster, is some of those stellar siblings will be bigger, more massive, burn through their nuclear fuel much more quickly, and then explode. So we've talked already about supernovae already. You really, as a life-bearing planet, probably don't want to be part of a star cluster, because some of your star's siblings might live fast, die young, blow up, and then wipe out all life on your world. And that'd be a bummer.
Yeah, it would.
Or turn you into a rogue planet.
Yeah.
Just yeet you out of your system gravitationally.
It doesn't have to be nearby stars, though, right? So when we form planets, we think the sun and the planets formed at the same time. And initially, that's sort of gas and dust when you have planets. And so that's where we think there may have formed more than 8 or 9, if you like Pluto. I do.
I do too.
Then you had more of them, and some of them haven't survived or have been what are now the free-floating planets. They probably formed around the star, but were kind of kicked out. And some probably crashed into each other. Like we think the moon is a result of kind of a crash, and that formed Earth and Moon. So it's a pretty violent process forming planets, and so you end up with some that live and some that don't, and some might have crashed onto their stars and kind of be swallowed by the stars, and some have been ejected to space and kind of in the eternal darkness.
I mean, getting back to the worst of all worlds, being swallowed by a star sounds like a pretty bad day for a planet too, right?
It probably is, yeah.
There's something very neat you could do with rogue planets, because they're ejected from star systems by the gravitational interaction of all the other planets swirling around. But we've also seen stars and probably planets as well being ejected from black holes, the black hole in the center of the galaxy. So if you wanted to journey from one galaxy to another galaxy, one way of doing that might be to engineer, some super advanced civilizations engineer the gravitational interactions to eject a planet in the right direction towards the next galaxy, so you can then ride it and have all the resources and the things you need to keep yourself going for the long, long voyage.
That would be incredible.
Rather than trying to build a spaceship, you would just turn your planet into a spaceship and fling it in the right direction.
Ping pong through the galaxy.
Exactly, yeah. So sort of sci-fi type scenario that we might be attempting as a species in the far future.
I like that. Well, so thinking about all of these terrible, terrible things that we've talked about, we sort of talked about it a little bit, but can several of them exist together on one planet? Like, what doesn't negate each other? We can have something like, would the worst planet have a star or not?
I mean, they're kind of both equally bad, right? having no star, no one. I feel like we're not playing by the rules of the game. Trying to say. Sure.
I think it should have a star. I think that the other ones are like cold, but there's not as much going on.
Yeah, I feel like a planet that's got the molten surface.
That sounds
very
worse than a
close
cold
to-
planet.
Right?
So you'd rather go to Antarctica for holiday than go to somewhere super hot?
Yeah, this is the question of whether you're sort of a winter or summer person,
Yeah.
right?
I am-
What
Do you think
prefer?
days are too hot, or do you think winter is the most miserable?
Frankly, I'm like more in the middle. I like a mild temperature. But
I'm a
I
winter
think
person.
hot sounds
so
worse.
All right. So hot world. So we'll have
Hot,
your
yeah, okay.
the floor is lava, molten surface planet,
The floor is lava.
orbiting
okay.
too closely to its star.
yeah.
And
Could
maybe
we do-
the star is gonna explode or have a bad day.
Yep.
Yeah.
That would do
Could
it.
we do a half and half? Would it be possible to have a planet where it's got a night side and only the day side is so hot that it's molten?
Or yeah. At some
Probably.
point, do you get too close?
Most of these planets kind of have a permanent day side because they're kind of like the moon. You see the same side all the time. So if you lived on the day side, you'd see the sun the whole time, and if you're on the back side, you actually wouldn't see the sun at all. So in that sense, maybe even if you're close, and it might still be pretty warm, you wouldn't actually see the sun at all, so it would still be dark.
Okay. Best of both worlds.
So we want hot and cold.
Okay.
It'd also be really stormy. If you've got one side of your planet which is incredibly hot on the sun side, and the far side where it's living in eternal nighttime, and the planet had an atmosphere, you would have the most incredible storms rushing from the day side to the night side. So you can have that as well. You can have a stormy hot planet.
Okay, and can we get that sapphire rain in there?
I think that, yeah, that should not be a big problem. Or
You're gonna play that
meteorites,
in for free,
meteorites
right?
falling on, that should be
If we have to live in
possible.
this terrible wind and this terrible planet, I want the sapphire
You want a
rain.
heavy bombardment of asteroids as well. Fair enough. You can have that.
Yeah, I feel like we're at a like cosmic restaurant, just ordering
Everything on the menu.
Exactly.
all the worst things on the menu.
Exactly. And then, but I do think, so to me, that's the worst, right? Hot, tidally locked, terrible winds, sapphire rain. But the one thing that's worse than that is engulfed. Like, I think this one exists.
Plunging into the star would
Right?
arguably be worse than all of that. I would agree with you, I think, yeah.
Yeah.
As your star reaches the end of its natural lifetime and expands out as a red giant, that would be the end of days, but also the worst day. You'd be saving the worst to last in terms of the planet's
Yeah, I think that's a
history.
good way to get engulfed as well. If you wait for your star to eventually grow in size, we know this will happen to the sun over time. It will grow. You'd kind of slowly see it grow until it eventually kind of comes towards you and engulfs you. So you'd see it happening over a long time. You'd see the star come closer and closer until it's not you falling onto the star, it's the star coming towards you, and eventually
But you're right.
you'll be engulfed.
The terror of watching it come at you is the worst part of that. Not even being on the worst of all
You'd
worlds.
sort of know how many years you have left. Yeah.
I mean, it would be over the course of generations,
It
right?
would-
you
it
wouldn't
would take
be
a while. It
seeing
would
take a while,
get
yeah.
closer.
I don't know. Come on.
I mean, I wish. But that is going to happen here, though, right? All the inner planets will be engulfed by the sun.
Yeah, the sun will grow in size, and then if the closer you are, the more in trouble you are likely to be. Right.
So
Makes sense.
I'm just saying, I don't have a vendetta, but this sounds a little bit like Mercury. Just a little bit worse.
It does
But
sound a
mostly
little bit like
Mercury.
Mercury. Very close, tidally locked. It doesn't have that sapphire rain.
It doesn't have an atmosphere, so we'd have to give Mercury an atmosphere.
And then we've made the worst of all worlds.
Mercury too.
We already did it.
I think that works. We got to
Yeah.
come up with a better name than Mercury too.
Yeah, we do. If anybody in the audience has a suggestion for the name of this planet, we'd love to hear it. Or if you have any questions for our guests, just raise your hand and let us know.
Hello. For a gas giant like Jupiter, could you have a life form that is like a bubble or something that is sentient, that could exist and would love those conditions but would hate ours? Similar to what you were saying earlier on.
Yeah, this is a mainstay of science fiction stories. It certainly appears quite a lot in Ian M. Banks' books, the culture novels, where they have organisms which are floating in the upper cloud decks of gas giants. And in a sense, the upper cloud decks, the upper atmosphere of gas giant planets are pretty pleasant. There's water there. From a human perspective, from an Earth-like perspective, it's a nice warm temperature, the pressure is habitable. The problem with thinking about life in the upper cloud decks of gas planets, of a gas giant, is how that life started in the first place. Because as far as we know, life on Earth got started on the surface of the planet, and probably in fact deep underwater, around hydrothermal vents on the seafloor. So you need, as far as we understand, the interaction between a rocky crust of a planet and a watery ocean and all the chemistry that drives. And it'd be really hard to understand how life gets started just drifting around in a turbulent upper atmosphere of a gas giant where you don't have a solid surface, you don't have a large body of water, you've got tiny little droplets. It might be a habitable environment, but you wouldn't have been able to evolve the life in the first place to inhabit that inhabitable environment if you think of it that way. One possibility, though, is you might be able to deliberately seed life into a gas giant planet. You could create life in perhaps a lab here on Earth that could survive the environment of the upper cloud decks of a gas giant, and then launch over there in a rocket and do a sort of directed panspermia, directed effort to colonize other planets with life.
Is this something we worry about when we send spacecraft? Because I know, like, the Cassini spacecraft went to Saturn, looked at Saturn and all of its amazing moons, and then it went into Saturn so that it wouldn't crash on the moons and contaminate them. But could something like that contaminate the cloud deck of Saturn?
We are definitely worried about it, right? So we definitely, when we send things to Mars, for example, we're also worried that we might inadvertently seed things there. In fact, we're kind of worried now if we find things on Mars, it might have been stuff we've brought. So it's not easy to make things completely clean before you send them to space. So we'll try to avoid it, but yeah, it's definitely a kind of a concern. Yeah.
Yeah.
We have a question down here.
Hi. I was just wondering, I don't know if my knowledge is outdated, but allegedly there was some kind of crazy tsunami raging around, or potential tsunami raging around Saturn. That's like the weird bell sound. This is this may not be true, but I just think like a raging tsunami would be a really good addition to a bad planet.
I
Yeah.
agree. A raging tsunami would be a fantastic addition to our bad planet.
The problem is, though, that if you have a tsunami, you need to have some liquid on the surface. And if there's water on the surface, it's not that bad. You're saying gas. Yeah, this would have that. If you have a tidally locked planet, as Lewis was saying earlier, you get all this energy being pumped into one side. And if there's an atmosphere, that energy is going to create these crazy powerful winds and storms. And it could get real bad.
Yeah, real bad, real quick.
I love the understatement there as well. It get real bad.
Real bad.
a bit nasty.
I was just going to ask the question, are we ever going to find life in the universe?
That's quite a question. Are we ever going to find life?
Yes.
Well, personally,
So certain.
I hope so, because I kind of bet my career on it. By choosing to be an astrobiologist, I'm betting my career that we will find something interesting in my own lifetime. Vincent?
Yes, I think is the answer shortly. Obviously we don't know for sure, right? But I think it's not so. If there's life out there, it's probably on a planet, and we're most likely to find it on a planet that's somewhat similar to Earth. And the first exoplanet, so now there's 5,000. The first one was really discovered in 1995. So in our lifetime, and now there's 5,000, and in the next years there'll be many more. It's still a struggle to find those that kind of look like the Earth, but we're getting closer and closer to finding things that are more and more like Earth. So in the next decade or two, we will have planets that are very similar to Earth that could potentially have life. We're kind of building the instruments that can study the atmospheres of those planets. We're hoping that we will find that some of those atmospheres have things like oxygen, which we know for the Earth, the oxygen is largely here because of biology. Right, so we know that the Earth, if it didn't have any life, would probably have a lot less oxygen in its atmosphere. And so we're hoping to say, if we look at a planet that's like the Earth, and it does have oxygen, then that might be an indicator that it does have life. It's not a slam dunk case, perhaps, right? It's not quite like seeing dinosaurs in your telescope, but that's kind of where we're at, and that will happen in the next 20 or 30 years, probably. And I'm expecting that we will, within our lifetime, start finding those kind of things that that the most likely explanation is life, and hopefully we'll get better and better to start imaging things more, and eventually find things, find even more clear evidence. But that's just our lifetime. So, I think people will find it, hopefully in our lifetime. But yeah, I would guess so. And I will even say that I think once we find it, we will realize it's very common, right? Right now we still kind of assume it's hard or it's rare because we haven't seen it. But I think we will realize once we started finding it, that we'll start seeing it a little bit everywhere.
I think the harder version of that question is, will we ever know for sure that we've found life? And, as you were saying, these places are all very far away, all these exoplanets. So, and we have all these ideas of how we might say, hey, this thing might be life. In fact, was it last year, a couple years ago, they found some compounds in Venus's atmosphere that they thought might come from life. And now I think it's widely agreed that they don't. But for a little bit, everyone was very excited. So I think it's going to be a lot of guess and check on that kind of thing.
Hello.
Hi.
Just an observation. As a keen science fiction reader, and I'm glad there's been references to science fiction, and some of the scientifically informed science fiction has been a good source of ideas, which can now be tested more than they could be in the past. Things like species who live below the surface level of a planet, either a gas giant or a rocky planet. In some cases can't believe that there are people like us who live in the cold and dark of the outside of the planet, and they don't expect to find us. But one of the best, I think, of these is Isaac Asimov's famous Nightfall, originally a short story, then a novel. And it does have that bit about how could they possibly live on a planet which has a simple orbit around a simple star and it's dark and light over a 24-hour period. Well, you know, how could they survive in a situation like that, where it was bright day and then bright night, alternating. And yet they're used to a very different scenario. And of course, as people may know, at the end of that story, night falls for the first time in 2,000 years. And the planet actually is in a cluster. 30,000 stars are visible, very different from our own night sky. But as has been said, that might lead to its own problems, being so close to other stars.
Yeah.
Many of which might be bigger than your star.
That's made me... Can I interrupt you? Thank you. That's made me think of on these tidally large planets, if you could have life, whether you would have two completely different ecosystems and completely wildly different life forms on the hot side and the cold side, and maybe a third one in the middle.
If Titan does have life, if the liquid methane and ethane lakes on the surface of Titan have life, there's also a very good chance that the molten magma inside Titan could also have life, because the surface of Titan is hard frozen water ice, so the magma beneath that is effectively liquid water. So Titan's got this intriguing possibility of maybe methane-based life on the surface, water-based life in the deep interior of the world, and two ecosystems which are based on fundamentally different biochemistry. They would never ever be able to meet each other, because if the magma life came to the surface, our kind of water-based life, it would freeze. If the methane-based life ever got below the surface, trying to meet the water-based life, it would boil and evaporate. And they're just based on two physically very different systems, which is a great idea, great sort of notion.
Fantastic.
Fascinating.
We have another question here.
So I just wanted to unpack a little bit of the contamination thing that you mentioned. I was wondering if anyone astrobiologically is trying to create, I don't know, microorganisms that can create atmospheres in other planets, and if not, why not?
So there is a huge area of science within astrobiology looking at some of the hardiest forms of life on Earth that could survive in other environments, and these are called the extremophiles, or extreme-loving organisms. And I have some extremophile bacteria growing in my lab at the university. It's the sort of bread and butter that a lot of astrobiologists work with. But I think your question was more about, could we sort of engineer life to survive? And by extension of that, another neat idea is, could we engineer life to perhaps start seeding on somewhere like Mars and make Mars more habitable for human life? And this is called terraforming. Could we make Mars more like Earth? And in fact, what we would be doing would be turning back the hands of time on Mars, because it was once much warmer and wetter with a thicker atmosphere than it does do today. We'd be trying to revert Mars to its primordial state, so that perhaps in the far future, hundreds and hundreds of years at least in the future, people living on Mars could go outside without wearing their spacesuit and not have their eyes pop out their skull and die
No accidental
within 30
blood
seconds.
boiling.
No accidental blood boiling. You could genuinely walk around on the surface of Mars. First, you'd have to wear an oxygen mask, but the pressure would be enough. And then in the future, the far future, could we seed Mars with things like cyanobacteria, hardy algae that could generate oxygen in the Martian atmosphere as well, so you could genuinely take a deep lungful of Mars air and not die. And that, again, is a mainstay of sci-fi, what we could do hundreds, if not thousands of years in the future as humans explore and spread beyond just our little pebble that we've evolved on.
Yeah. I mean, going back also to the previous question, I think that extremophiles are part of why we can be encouraged about finding life somewhere else, right? We kind of know on Earth, we look at pretty extreme environments and we still find life. For example, really deep into the ocean, right? Really deep in the ocean where there isn't actually that much light at all, you can still have life on Earth. And so that's encouraging if you look at these kind of crazy planets that we've discussed earlier, that maybe in some of these environments you could still have certain kinds of biological processes if they can happen in the deep in the ocean, right? Again, if an alien was discussing the Earth, they would say, okay, deep in the ocean it's not possible, there's not enough light. On the surface, well, every 24 hours things get this bright and then dark. It's really hard. So in the end, on Earth at least we know there's kind of different kinds of life in very different places, some very extreme. So maybe some of these pretty extreme planets we discussed are only extreme to us, right?
Yeah.
it sounds like maybe actually Mercury 2 might not be the worst one. It might be that one that's evaporating, because things live in a lot of weird places on Earth, but if all the places are disappearing...
Yeah, then we're really in trouble. Did we have another question?
Hi, I wanted to ask, in terms of Mars, what do you think are likelihood of finding either evidence that life did exist at some point or currently still exists is within the next sort of 10, 20 years?
No, I'm not sure I quite caught the question. Was it what evidence is that the life did exist on Mars?
Was it, do you think we'll find evidence?
It.
I can go, and I think yes. I think we'll find evidence that life did exist. I'm leery about the possibility of finding life there now, given the lack of atmosphere and the temperature. But correct me if I'm...
I wouldn't disagree with that. I think we're more likely to find fossilized bacteria, microfossils on Mars, than anything surviving the incredibly nasty environment today.
And I think it's maybe good to emphasize again, I know Lewis said earlier, when we're talking about life, for the most part, we're talking about bacteria and microbes, not you and me. Because if Mars, or if any of the other worlds nearby, had supported life that was people, or dinosaurs, or mice, we probably would have found some evidence of that very quickly. We've changed the surface of the Earth so much.
Yes, we have another one.
Hello. You guys have been talking about how naturally bad they are bad planets. Could there be life that have damaged a planet, but it's not natural in a way?
Well, actually,
Yeah.
we're possibly on the brink of making non-natural life already. So there's been a lot of talk in the newspapers about artificial intelligence. We could also be talking about artificial life, maybe silicon-based life, life that is based on silicon chips and computers rather than messy organic molecules and water. So it's not inconceivable that in the near future we can create artificial life or silicon-based life, computer-based life, and maybe start shooting that out into outer space. Because computers are far hardier than a human astronaut could ever be. So if we're going to be exploring our solar system, rather than trying to send human astronauts and the entire spaceship around them to stop them dying in space, we can send much, much smaller and therefore much, much faster space probes that are intelligent and maybe could reproduce and sort of recreate themselves when they land on another planet, and send those out into the galaxy. So by some arguments, artificial life might be much, much more common than natural life, if you like it, in the galaxy. Because natural life can make artificial life.
Yeah, and you wouldn't even need like the freeze-dried ice cream and all that, right?
Nope.
Easy peasy.
I think I heard the question a little bit differently, but that was fascinating, so I didn't want to stop you. About, like, could life ruin the planet that it was on? Yeah. And I think the answer to that is tragically and unfortunately very much yes. I think, certainly human life has had deleterious effects on Earth. And I think if you were actively trying to ruin a planet, you could do a lot worse. I mean, I can think of a lot of ways that I could mess up a planet if I was doing it on purpose, not least of which...
Right, but maybe like life there wouldn't be doing it on purpose.
Yeah, but the question was, could you ruin a planet? Yep.
Oh, okay.
Sure could. We talked a lot in some of the other episodes about the idea of moving a planet and the idea of basically putting big rockets on the planet to move it, which is the idea we got from the book Wandering Earth by Cixin Liu.
Yeah.
And so if you could strap a big rocket onto a planet and scoot it over, even just not that much, and destabilize its orbit, I think that would ruin it more than anything else, aside from throwing another planet at it.
Yeah, smash two planets together and you really ruined both of them very quickly.
That one's not possible with today's technology.
Yeah.
Yeah, I mean, maybe all of this is also a good reminder that although maybe lots of these places could harbor some kind of life, basically none of them are good for us, right?
Yeah.
So, there's no real prospect that humans should be going to live somewhere else. I think for us, Earth is definitely by far the best place to live, and there isn't really a kind of good alternative for us, so we should try not to ruin Earth, probably.
Take care of it, yeah. I think I don't see any more questions, so thank you all for coming. We've really appreciated having Lewis and Vincent and all of you here at New Scientist. Thank you so much.
And just a reminder, Lewis has a book signing right after this at
the Blackwells.
G1, which is over there. And thank you again for coming. Really appreciate it.